Imagine the dreams of ancient alchemists coming true at the cutting edge of scientific research. Welcome to the Large Hadron Collider at CERN, where scientists have achieved something truly remarkable, transforming lead into gold. But this isn't about getting rich. It's an incredible side effect of studying some of the most fundamental aspects of our universe. The LHC's primary goal is to create and study a state of matter known as quark-gluon plasma, or QGP. This exotic substance is believed to have existed just microseconds after the Big Bang. To recreate these conditions, scientists accelerate heavy ions such as lead to nearly the speed of light and smash them together. During these high-energy collisions, protons and neutrons in the lead nuclei break apart into their fundamental components, quarks and gluons. But that's not all that happens. The immense energy can also strip away or add protons and neutrons, leading to a fascinating transformation. Some lead atoms, which originally have 82 protons, lose a few protons and turn into entirely different elements. If a lead atom loses 3 protons, it becomes an isotope of gold. Lose 4 and you've got platinum. Researchers at CERN, analyzing the aftermath of these collisions, have identified the signature gamma-ray emissions from these newly formed, unstable isotopes of gold and platinum. Now don't get too excited. We're talking about just a few hundred atoms per experiment. It's not enough to mint your own gold coins, but it's enough to prove that alchemical transmutation is possible. At least with one of the most powerful machines on Earth. This isn't an economically viable way to produce gold. The energy and resources needed to run the LHC far surpass the value of the gold produced. Ancient alchemists wanted to turn lead into gold cheaply. Modern physicists have done it, but at a cost that makes it impractical for wealth. The real value lies in what it tells us about physics and the universe. These experiments shed light on the strong nuclear force that holds atomic nuclei together and the behavior of matter under extreme conditions. They help us understand nucleosynthesis, the process by which elements are formed in the universe, particularly in events like neutron-star mergers, where heavy elements such as gold and platinum are forged. So while the LHC can technically turn lead into gold, its true purpose is far more profound. It helps us explore the fundamental building blocks of the universe and the forces that govern them. It's a testament to how far we've come, transforming an ancient mystical pursuit into a real, albeit small-scale, triumph of modern science. Thanks for tuning in to this incredible journey into the heart of matter. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more fascinating science stories.